Hello everyone to this video on the visitor pattern. I see a lot of videos on this topic, and for some reason it's still not very clear to many people what this really means, what the visitor pattern is used for. So this will be my take on why I think the visitor pattern is useful and the places where you should use it. So there are three questions that we'll try to answer in this session. So the first one being the why. So why do we need the visitor pattern? So visitor pattern is really useful in places where you have object hierarchies, where each object that you have can be of a type A or something that extends A. So we could have something like object uh, an object that is of class type B which extends A, or something like C that extends A. So this will look something like this. So basically the idea is, when you have this sort of a pattern where you have objects that can be of many different types and you do not know exactly which type you have at runtime, so you end up creating a lot of if conditions and try to typecast them to some type, and if it is of that type you do something, otherwise you have something that's of a different type, so on and so forth. So wherever you see a pattern where you have to create a lot of if else conditions, add a lot of um, type type checks in the sense to see if an object is of a specific type, that's the problem this tries to solve. So this will try to eliminate the need for typecasts in many places, so you won't have to do the expensive typecasting. So you could say one of the main reasons we do this is to avoid expensive typecasts. And in addition to this point, the main thing is the code that you write with respect to a specific type of object. If it is going to be unique per implementation, in that case it's really useful to have the visitor patterns, provides a clean code base. So these are in general the two main points of why you would use the visitor pattern. It is not that complicated. The main thing is to avoid the expensive typecasting scenarios and to get out of the if else hell, that is sometimes what people refer to it as. And the where is this primarily seen by us computer engineers? So one of the main places that you will always find the visitor pattern being used again and again is interpreters and compilers. And it is in general very extensible to working with different type of tree based structure. So not getting much into all the uses, so main thing you will have to remember is interpreters and compilers are the one for whom this pattern was sort of invented, you could say. And there are many other use cases, depends on the use of or the programmer. And the third thing is how. So this is what we'll be focusing on. So in order to explain this, I will be using the concept of the interpreter. So we will be trying to implement an interpreter, a very basic one, not a lot of fancy thing. So basically, we will have an interpreter which will evaluate mathematical expressions. So we'll just have like basic expressions, let's say 3 plus 2, 3 plus 2 into 3, something like that. So these are the things, these are expressions that we will see how the visitor pattern makes it uh, really easy to work with interpretation of these sort of statements, and in general any programming language. So if you were to create a parser or that sort of a system, in that case you would be working with the visitor pattern a lot. So why is there a need for this visitor pattern? So if we try to look at it in a very broad view, you would see that a program in general consists of statements, something like this: b is equal to 2 into a. So let's say we have these two lines of code, and what the computer does is there is a step which involves parsing, and that's called the front end. So its main task after processing this text is to convert it to a form which can be run by the computer or interpreted. So what we would end up seeing is that it creates a structure known as the AST. You can look it up on Google. It's called the abstract syntax tree. So what this abstract syntax tree allows us to do is to just extract information out of this piece of text. So it puts it in a meaningful form. In this case, it would look something like this. So for line 1, let's just look at line 1 first. And it would be something like this. And then you would have plus, and then you might have, let's use different colors, 3 and 3. So this would give us this sort of a abstract syntax tree, and you will notice that this tree is comprised of a lot of nodes. So everything is a node here, and the interesting part is all the nodes are not of the same type. So it is possible that some nodes have two things to them. So is equal to has a left thing which says where it should be stored, and this says what should be stored, plus expression node says these should be integers and these should be integers and they must be added up and sent back. So all these nodes have some intrinsic understanding as to how to use them, right? So all of these we can say, so this node would become assignment node, and this will extend the general type node. So you would have a lot of these nodes where you would have like plus node, let's say, and this plus node will also extend the type generic node, and even these are nodes, so there will be integer nodes which again extend the type node. And so why we have a general type node is because obviously everything is a node in this tree, but when we store or read the program, we do not know exactly what node it is, so it makes not much sense to store explicitly the type of the node, because when you create an array or something, it's gonna be homogeneous, and uh, it is expensive or not even possible in some cases to store the type of the node explicitly. Okay, after the short hiatus, let's resume. Yeah, so we are looking at these nodes of this abstract syntax tree. So the main takeaway is this is a tree that has a lot of different kinds of nodes. and based on this type, we try to do something, right? So based on this type, we decide an action. So this is the main premise. So this is the thing. So main thing is that there are different kinds of nodes. So here we have one, two, three, four kinds of nodes, and these four kinds of nodes are inheriting from the same generic node object. So you can store this whole thing just as a collection of nodes, and that should be easy to do. So uh, this is exactly what an input from the this is what the output of the lexical and syntactic phase looks like. So this is what a compiler actually does. Parser first creates an abstract syntax tree. So this is one of the most important things that happens whenever you run a program. So this data structure requires a lot of thought to be put into it, right? You cannot add a typecast or a check for every single stage. If that were the case, the real world programs would run like extremely slowly. And in order to solve this, smart people have come up with methods like this visitor pattern. And the interesting point is this is just a hack, and this is not, I wouldn't even call it a very explicit pattern with a lot of rules, because it is a hack in simple words, because it mimics or recreates a functionality that is missing from the language itself. So this functionality that we know as multiple dispatch is simply not available in languages like Java, C++, so on and so forth. So a lot of these regularly used languages do not have this functionality of multiple dispatch. So we cannot create multiple dispatch that easily. It is a very tricky functionality to implement, but we can create a version of it or a stripped down version of it that is just double dispatch. So multiple means n and double means 2, so no confusions there. And what we have is single dispatch. So if you're not aware of what these terms actually mean, you do not need to care, because it sounds more complicated than it actually is. So once we get to the implementation, it will become very obvious what this actually means. So just for good measure. Okay, so this is the problem that we are at. So we were given an abstract syntax tree, which is a set of different kinds of nodes, and based on that we need to implement their functionalities separately. So one of the ways in which we solve it is the visitor pattern. So how would we go about doing this? Okay, so let's look at the naive approach of how one would try to solve this problem. So let's say we start from this node. So this is node 1. So once we come at node 1, we check if the type is if the node is of type equals node, and if the node is of the is equals type. In that case, we know that there will be two children to this, so we'll have a left child and right child. And then after that, we have to see what kind of a child left and right is. And you see that we come into a weird place where the left one needs to have one more if else check, and the right needs to have a bunch of if else checks, because the right of a is equal to node might have something like a is equal to 2, a is equal to 2 into 2, and whatever. So there are multiple possibilities of what could be, what type this node could be. So you would end up adding else if so, and all these checks are going to be typecast, and every time you typecast it is super expensive. It puts strain on, and yeah, typecasting is not always error safe, so error handling must also be done properly. And if you miss one place, then welcome to segmentation faults. So there are a lot of possibilities of things failing left and right. In order to avoid this entire situation of reading one node, then doing type checks, then again on the next node doing type checks, and again, in that case, we won't be able to reach far, and it's going to be a huge challenge. So in order to solve this, let's take up three examples. So let us say we are given these 3 lines of code, and this is our program, and we are trying to run this in our interpreter, and these are the abstract syntax trees that are given to us. So we will write code because that's the most easy way to solve this problem, and that's what it's intended for. So let's see how it works. So I'll just first quickly go through the theory, and it might not really be that obvious when we are doing it in theory, but you will quickly see how it works. So what the visitor pattern says is that okay, we have n different kinds of nodes, that is all right, all sweet, but the point is all the nodes are going to implement an interface. And if you do not know what an interface is, it's quite simple. So it is just a very harshly said sentence that just says that this class should include this method. So if I say the interface says that it should have a print method, then every class that derives from this interface should have a method that does this. So it doesn't say what the method does, it just says should have a method. So it should have a method named that we can call should have a method. So we use this concept for the concept of nodes that we have. So each node is forced to have a method that is called as an acceptor. So accept, each node must be able to accept a visitor. So this basically means is we should be able to take an object of type visitor, and each node should have a method accepts that is able to take this visitor. And what this method does is also quite trivial. What this does is it simply just says each visitor should also have a method visit. So it would look something like this: v dot visit, and to the visit method, yeah, so and to the visit method there can be a lot of possibilities, right? So we call the visit method with this, the current node. So we pass ourselves to this visit method. And why this works and why this is important is quite easy to see once you look at what the visitor does. So the visitor is something that is supposed to implement the functionality, right? So the interface of the visitor says that the visitor should be able to visit. The only purpose of the visitor is to visit each and every unique kind of node. So let's say we have a plus node, and then you have, after the plus node, you have a integer node. after the integer node you have so on and so forth. So you have like n nodes, right? So visitor's main job is to just be able to visit each kind of a unique node. So this is the entire visitor pattern. So this basically allows you to go to a node, then depending on the type of the node, invoke a special function that is unique to that node, so that is supposed to process that node. So it becomes quite trivial. So once you have this understanding that this will just call, so once you have a node, then you will just be able to accept a visitor, and the visitor will visit a method that is supposed to act on this type of a node. And in doing this, we see that when we pass the this pointer, the type of the node is implicitly given. So this pointer knows the kind of the node at which I'm at. So just to recap, so once we are at a specific kind of a node, we will be able to call a accept method, because the interface says that the accept method should always be there, and the accept method should and always will be able to accept a visitor because the interface says so. And the visitor is quite smart. So visitor says that okay, I'm a visitor, so visitor should be able to visit any method, and on the basis of what is provided to me, I will decide to invoke some version of the visit method, and this pointer is passed to it, and this pointer basically points to the current runtime type of the object. So type of the object is basically everything is a node, and after being a node, it can be a plus node, minus node, or anything. So this is the known type that we can say looking at the code, but this is the runtime type. So when we pass the this pointer, instead of this generic node, we will be able to pass the plus node information to the visitor. So the visitor happily sees where to go, and using this it can route itself to the visit method, and that's what is the functionality of multiple dispatch. So what single dispatch does, now it's quite clear to see that if we have an object of type A and A has a function foo, let's say, if we call a dot foo, the only thing that one needs to know is the type of the object A, or the runtime time of the object A, and using that we can resolve which foo method must be called. Okay, resuming the recording. Alright, so we were discussing single and multiple dispatch. So let's quickly recap of what we are thinking. So let us say that we have object of class A, and class A has a method foo, and let us say that okay, let me just write down the entire code thing so there are no doubts as to what I'm trying to say. So let's say there is a class A and there is a class B that extends A, and there is a class C that extends A as well, and we have a virtual method named foo, and so all of these classes will have a method foo, and we could have a situation in C++ where we create an object pointer of type A and assign it to an object of type B. In this case, you will notice that the static type of or the object A is of class A, but if you look at its runtime type, it is going to be of type B. And why this is important is based on the runtime type of the object, we would decide what this foo method which foo method gets called. So it's just a pointer. We have no idea as to what type it could be, and we know that it's a virtual method. So at runtime, we will figure out that okay, this object pointer actually stores an object of type B. So let me dispatch this method. So this is what a single dispatch system does. So in a single dispatch, we dispatched based on the runtime type of the caller. So this is all well and good, but there could be a situation where we have these three classes and we have, let's say, two classes A1 and A2, which A2 extends A1, and the foo method accepts an object of type A1, and there lets there be one more method foo that accepts the object of type A2. And same here as well, we have one that accepts A1, and here we have another one that accepts A2, A1 and A2. So in this case, once we create an object of type A1 and we store it in an object O, so this would look something like O, and we actually have the runtime object of type A2. So if you notice, what we have done is we have created a pointer of type A1, but in that pointer we are actually storing a reference of type A2. So what ends up happening is the object here actually contains an object of type A2 and not of type A1. But in a single dispatch system, if you were to give O to this method, instead of resolving the runtime type of the argument, it would simply see the static type, that is A1, and dispatch incorrectly to this method or this method or this method. So these three methods think that the argument is of type A1. So in this case, we can say that the system does not support multiple dispatch because the dispatch is only dependent on the runtime type of the caller and not arguments. If the system supported multiple dispatch, these limitations would be gone and we would dispatch a method based on the runtime types of the caller as well as the argument. So this is a slight detour on what single and multiple dispatch means. So let's now get into code. So in code we have these three lines of code that we will be trying to interpret in our naive interpreter. So let us see what we have done here. So we have the visitor pattern implemented here. We have a node, or we have a class of type node or a struct. In C++, both of them are exactly the same. The main difference being, in a struct, by default all the methods and the fields are public by default, and we want everything to be public, so it's easier to use a struct. No problem using a class as well. So we can see that we have different kinds of nodes. We have division, multiplication, subtraction, addition, integer literal, and a basic type node. And all of these nodes extend the basic structure node or the class node, and all of them have some different intrinsic values that they work with. And you will see that we have defined two virtual methods. one is the get type and one is the accept method, and this is the one that is important, as we had pointed out that the visitor pattern says a very simple thing, that everything should have an accept method. So all the nodes have an accept method that accept a visitor. And if we scroll down, we will see that all these accept methods look exactly the same. Their main purpose is to just return the value of this type, and the main point being that this pointer is passed as an argument to the visit method. And if we look at the visit method here, the visit method, based on the type of the node that is calling, it dispatches to a different method. So if I were to call the visit method using the integer literals visitor, so at this point, in this case, the visit method that gets dispatched is this visit method. And in case if it was a subtraction expression, even though it looks the same because of the multiple double dispatch that we are trying to mimic here, what would end up happening is we would try to call the visit method, and when we pass the this pointer has the intrinsic understanding that I am a sub expression, and a sub expression is the information that visitor also has at this point, and based on this runtime information it will be able to dispatch to this method. So quite simply we can go ahead and write the code as follows. So in this case it's very simple. If we find an integer, we return an integer. In the case if it's an add expression, we return the result of accepting the left and right parts of the subtree. So what this means is, once we are here, the right subtree and left subtree are accepted, and once we accept those, we will reach these visit methods, and these visit methods do nothing but simply return the value of the node, which is 2 and 3 in this case. So what will happen is we will first visit the add expression, the add expression will get these two values, and then we just return their summation. And this is the program. So this is the demo program that gets created, nothing fancy here. So we are just creating that exact same tree that we had shown, and then we just call this one by one. So this is the basic understanding of what the visitor pattern does. So to have a quick recap of everything that was covered, is the visitor pattern enforces that we, at the point where we are going to change a lot, so that is the nodes. So we have many different kinds of nodes. So the places where there is a huge amount of abstraction, instead of individually implementing the algorithms or the facility inside a different class for each nodes and doing things that way, what we do is we simply create an acceptor. And the acceptor's job is to accept a visitor. And the visitor will use the runtime type of the node. And once we know the runtime type of the node, we dispatch to the correct visitor. Okay, so I hope this was not super complicated to understand. So this is what is the visitor pattern and how it is used in real world scenarios.